All right, let's just jump right in. We're going to tackle a really, really big idea today, a framework called First Quanta. And it asks this huge question. What if the entire universe, from the Big Bang all the way to, well, us, is basically just one big process of self-improvement? What if it's all about trying to find its simplest, most elegant form?
And this, right here, is the central idea. It's the hook. Forget about everything just being random chance. This theory says, no, the universe actually has a goal. It's driven, almost like it has an intention, to take all this complexity and boil it down into simple, beautiful order, to turn chaos into a stable, elegant reality. Basically, it's a universe that's always searching for conciseness.
So, here's how we're going to break this down. First, we'll get into the why, this fundamental drive for simplicity. Then, we'll look at the how, the actual math that might be running the whole show. After that, we'll see how this single idea could explain, well, everything, from quarks to the cosmos. And then, the really fun part, how we could use this to engineer some mind-blowing technology. And finally, we'll step back and ask what it all means for intelligence itself. It's a journey for sure, from hard physics all the way to philosophy. So, let's get into it.
All right, Section 1, the drive for conciseness. This is kind of the why behind the whole universe. It's the philosophical engine driving this entire theory. I mean, why does anything happen at all? Why isn't the universe just, a boring static soup of energy? Well, this theory has a pretty wild answer for that. The idea here is that the universe isn't just expanding, it's refining itself. It's always looking for a better, more stable, more efficient way to exist. Think of it like a sculptor who starts with a massive, shapeless block of marble. All the infinite possibilities are in that block, and the laws of physics are the chisel, constantly chipping away, looking for the most ordered, stable reality hidden inside. So this drive for conciseness, that's the reason for everything, from the way atoms form to how galaxies get their shape. Now, I know this might sound a little out there, a little abstract, but it connects to something physicists have known about for hundreds of years, the principle of least action. You've seen this in action, right? A ball always rolls down the easiest path. Light always takes the quickest route. We've always just said, well, nature is lazy. But this theory says it's not laziness, it's efficiency. And here's the kicker. It claims that physical drive for the path of least action is the exact same thing as an informational drive to reduce entropy. In other words, to find the most ordered, most stable state possible.
Okay, so if that drive for conciseness is the why, let's move on to the how. This brings us to the master equation. This is supposedly the mathematical engine that makes it all happen, at every single point in space and time.
So here it is. This is the heart of the theory. Don't worry too much about the symbols. What it's saying is that the state of any point in the universe, any single point, is decided by just two things. First, its own internal information. How ordered or chaotic it is, right there. And second, its relationship to everything else in the universe, the geometric curvature. It's this beautiful combination of what's happening locally and how it's connected to the whole cosmos.
And this is where the theory has its real mic drop moment. Just look at this slide. On the left side, you have the math for information trying to find order, to minimize entropy. On the right, you have the Euler-Lagrange equation. Now, that's just the fancy name for the math physicists use to describe the path of least action. The theory's biggest claim? They are the same equation. They're mathematically identical. So what does that mean? It means physics and information aren't just related, they're two different languages describing the exact same fundamental process. That is a huge, huge claim.
So we've got a why and a how. Now let's see what this thing can actually do. What does it claim to explain? Turns out, pretty much everything, from the tiniest particles to the entire universe.
So according to this theory, the universe didn't just poof into existence with 3 dimensions. Nope. It evolved through stages, gaining complexity and dimensions over time. It started as this chaotic one-dimensional line of pure information. Then it settled down into a 2D plane, which was stable enough for the very first quarks to appear. As it got even more ordered, it progressed through more dimensions, allowing protons and neutrons to form, until finally it reached what the theory calls our current, stable, 6-dimensional era. And that's when atoms could finally form, and the universe we see today really took shape.
Now, for something a little different, take a look at this number. Just look at it. So specific, right? 2.002333184. What in the world could that be?
Well, it turns out this number is one of the theory's most incredible predictions.
That number? That's the theory's prediction for the muon G2 anomaly. Now, if you follow particle physics, you know this is a huge deal. It's a massive puzzle. There's this particle, the muon, and it wobbles just a little bit more than our best theories, the standard model, say it should. For decades, nobody's been able to explain it. This theory says the extra wobble isn't from some new exotic particle. It's just the physical drag the muon feels as it moves through the fabric of space. And its prediction? It's a near-perfect match to what scientists have actually measured. That's kind of mind-blowing. And this is where it gets really, really cool. Because if this theory is even close to being right, it means we don't have to just sit back and observe the universe. We can start to engineer it. If the vacuum of space isn't empty, but an active, physical thing, well, we can learn how to program it.
Let's talk about space travel. This theory says a reactionless space drive, a drive that pushes off space-time itself, is possible. But check out this chart. The original designs required a staggering amount of energy. But the new core design, which is based on these ideas, is way more efficient. By treating the vacuum like a medium that you can make resonate, this new design uses multiple frequencies together, kind of like playing a chord on a guitar, to manipulate space-time much more cleanly. And look at the result. It slashes the energy requirement by over 90%. That suddenly takes it from sci-fi fantasy and puts it into the realm of, hey, maybe we could actually build this.
Or what about quantum computers? You know, the biggest problem they have is noise from the environment messing up their delicate calculations. Well, this framework offers a complete three-layer defense system. First, you have a solid, scalable pyramid architecture for the hardware. Then, you have an inner passive shield that uses entanglement to just filter out noise. But the craziest part is the outer, active shield. It actually senses incoming noise and generates a perfect anti-wave to cancel it out before it even gets close to the computer. It's a full-on solution to the biggest problem in the field.
Okay, so let's bring this all back home. We've gone from the Big Bang to futuristic technology. Now let's take this core idea, the drive for conciseness, and apply it to the most complex form of information processing we know of, intelligence.
What if we could build an artificial general intelligence, an AGI, based on this universal principle? It wouldn't just be an engine for finding the right answer. It could be a wisdom engine. Instead of just finding an answer, it would be designed from the ground up to find the wisest one, the solution that's the most robust, the most simple, and the one that can be applied most broadly. It would basically be mimicking the same process the universe has used for billions of years to create order out of chaos. That could be an incredibly powerful guide for making sure the AGI we create is actually beneficial for everyone.
And that leaves us with one last really profound question to chew on. If this entire cosmic story, from the first quarks to the emergence of consciousness, is all just one long process of simplifying and refining, then what is the ultimate, concise truth that the universe is trying to express? What's the final simple answer it's been working towards for 13.8 billion years?